Hi and welcome back everybody. In this episode we are building the Ethereum Connection Layer for this NFT marketplace. If you're new in here, hey, I'm Robert, and in this YouTube series you'll learn how to build a full stack NFT marketplace with or without lazy minting. If you have not seen the live demo in the first video yet, then please do so now before continuing with this video. Today we start with setting up a hardhat development environment with a local blockchain node. Then we build an interface module that enables us to connect from the client side through client wallets like Metamask, but also from the server side through our Next.js backend APIs that we are going to build in the following videos. As a bonus track at the end of the video, I'll show you how to fix an annoying Metamask connection issue. If you like this content, smash the like button below and subscribe to this channel. Now let's go! We change into our NFT Marketplace directory and we install hardhat with npm install hardhat. Then we need to delete the README file that was previously installed by Next.js. Now we can inject the hardhat basic configuration into our project by running npx hardhat. And we accept the default settings. Also, we accept the default modules which hardhat will install. Now we can open the hardhat.config.js file, and here we add the hardhat network configuration as follows. We need to set the hardhat chain ID to 1337, since this is the chain ID that Metamask expects for local networks. Now we split the terminal window here and we start our local hardhat Ethereum node here with npx hardhat node. Hardhat sets up several accounts for us with an account address, private key, and 10,000 testnet ETH for each account. Now we can open the Metamask browser and switch the network to localhost 8545. And here you can import the testnet accounts. I would recommend you to import at least 3 testnet accounts here by entering the private keys. So now we have the prerequisites to connect our app to our local Ethereum node with these accounts in Metamask. Now we can start building our Ethereum Connection Layer. We create a new directory and we name it Interfaces. Now we create 3 files in this interfaces directory. We create interface Ethereum.js, interface marketplace.js, and interface NFT.js. You can name these modules any way you like, but I decided to prefix these modules with interface if they interact directly with the blockchain or with smart contracts. We will build this interface Ethereum module right now, and we will build the other 2 interfaces later when we have the smart contracts available. The first function we write here is the connect function, which is an async function without any arguments, and we expect it to return a signer object, signer address, and the chain ID. In order to connect to the blockchain and to return the relevant data, we add these lines of code. In the first line, we get the connection through the getConnection function. The getConnection function we implement as follows. If we run on the client side, then we get a client connection. And if we're on the server side, we get the server connection. If we are on the client side or on the server side, we determine with this function if we are running this function on the server side, then the window is undefined and this function is server side returns false. In order to get a client connection through Metamask or any other client wallet, we use Web3 modul. We install Web3 modul as follows. Now we can write the function get client connection and get the connection through Web3 modul connect. Whenever the user changes his account or the chain gets changed, we reload the window and connect again. Here we return the connection. If we're running on the server side, we get the connection string through the getServerConnection function through a .env file which we pass with process.env. Once we have the right connection in our connection function, we can request a provider through a new getProvider function which takes the connection as argument. In the getProvider function, we differentiate again. If we run on the client side, then we use the Web3 provider and pass the connection. And if we run on the server side, then we use a JSON RPC provider. Once we have the right provider in the connect function, we can get the signer from the provider and the signer address as well. Then we get the network from the provider, and from the network we can get the chain ID. Finally, we return the signer address, and the chain ID. We also write the function getActiveAddress, which returns the signer address from the active connection. In the previous video where we created the frontend, we just displayed a dummy address here. So now we can go back to the connection component that we created in the last video. And here we delete this dummy address. Instead, we create a use effect hook here. Within this use effect hook, we can now call this new function getActiveAddress in the module Interface Ethereum, which returns the signer address. And here we update the account state variable. If we switch back to our browser window, we can see that now the active account address is displayed. Whenever we switch the account in Metamask, next we write another important function in our Interface Ethereum module named initContract. This function takes the smart contract address and the smart contract API as arguments, and it gets the contract and it returns the contract, the chain ID, the signer, and the signer address. We will use this function in the next videos whenever we want to interact or switch between smart contracts. As a bonus track today, I will show you how to fix this unchecked runtime last error could not establish a connection here below. This error occurs the first time you open your browser, and it is a known Metamask bug. It doesn't just occur in our app here, but also on a regular browser window when you open the browser for the first time, when Metamask is installed. To fix it, we switch back into our interface Ethereum module. And here we write the function maybe fix Metamask connection. This function basically checks if Metamask is installed, but the Ethereum state is not initialized. If the Ethereum state is not initialized, it waits 10 seconds and then it reloads the window. The 10 seconds are defined here in the wait seconds, and you can change this or adapt this to your needs. Then we go back to our connection component and call this function right before we try to get the active address. And this time we can see that it fixes the connection error by reloading the page again. And you can see that the Metamask browser window gets opened automatically. We open the developer console and we can see that the error is gone. Stay tuned for the following videos and thank you for watching.